Welcome to Guy Aitchison's Reinventing the Tattoo, where tattooers, apprentices, artists, and just the curious, not just the curious, and the curious, are welcome to come and learn and share and be inspired and ultimately get better tattoos. Today's a great Reinventing the Tattoo podcast show with a really special guest. We've got John Swierk. I'm horrible with the names. My pronunciation is horrible, but Guy got it right the first time, and it's going to be awesome. He's a chemist, so we are going to learn about what he has learned about tattoo inks and how they react to light and in the skin and all of that. And obviously inks are something we are all very interested in learning about now. So you can find, I don't know where you're beaming in from. We're on the Facebooks and on various YouTube channels, but if you always go to either of the app stores, either Apple or the Google Store, and download the Reinventing the Tattoo app, then you will always find the latest schedule for the live streaming. We're beaming out about 5 to 7 times a week now with awesome, again, inspirational tattoo programming, as well as the library, the growing inspirational archive of all of these shows. There's drawing groups, there's art jams, there's instructional videos for painting and all sorts of discussions. It's great for your front room or for listening to and while you're getting tattooed or doing tattoos to let the time go a little bit quicker. And it's anyways, it's very inspiring. So thank you for tuning in. You could also find us on the brand new Reinventing the Tattoo podcast. I thought I was going to say YouTube channel, but that's almost new. Catch us either on the podcast stores. We are up on Spotify, Reinventing the Tattoo podcast, and Apple's going to catch up pretty soon. If you're watching a replay, it should be up. And the brand new Reinventing the Tattoo YouTube channel. And please subscribe or follow it, and then share it around a little bit. It's brand new, so we could use a little juice. Okay, we have... let's see, I want to plug our sponsors because they help actually make this free for you. Inkjet Stencils is a system where you can create your tattoo reference right there on your iPad or your computer and print it out from your eco-friendly tank Epson printer. So you could do intricate stencils, but you're not like ruining your hands or taking tons of time. It saves some dough. And they have some webinars inside of the app, as well as you can go to inkjetstencils.com. Loose Screw Tattoo is an awesome tattoo shop in Richmond, Virginia, led by Jesse Smith. He has a couple interviews and webinars out across the internet. Do a search for Jesse Smith Tattoo Interview, and you'll find a whole bunch of them. He did one recently with us, particularly about awesome tattoo shop environments and whatnot, and what kind of people are great to work for and work with, and how it's a little bit about his journey. Anyways, loosescrewtattoo.com. Click the join our team. Wicked busy, and there's actually health, dental, vacation, 401k options if you want to have a real career. It's pretty sick. He's also obviously big into art nights, all that. Let him know that Reinventing the Tattoo sent you. Rawpigments.co is a tattoo pigment company, ink company out of California, and they are, I believe, acrylic-free, vegan. They're getting their pigments right from the source. They're very knowledgeable about what's going in, and we're excited to have them on board. You can get some samples of the raw pigments, as well as Cheyenne has a mess of cartridges and some little backpacks. This is the Reinventing the Tattoo goodie bag. If you want to get it. Actually, currently the best way to do it is you'll be not forced to, but you'll be excited to watch the Equinox party replay. Go to reinventingthetattoo.com/Equinox. You could sign up for the replay, and then on that watch screen, not only is there an awesome hour-and-a-half video of Android Jones doing amazing visuals you see behind us, and Aja Lu doing amazing sounds, which I probably should be playing, but you'll check it out on the replay. Underneath, you'll find the form to fill out for these goodie bags. And so, so you get some raw pigments, you get some Cheyenne cartridges, and maybe some other good stuff in there. And okay, so I am going to, affiliates. Check out the Fireside Tattoo Network. It's an amazing podcast and YouTube channel hosted by Jake Meeks, The Apprentice Diaries, hosted by Amy Nichols, that focuses on the apprentice journey, primarily in tattoos, but she reaches out to all sorts of other apprenticeships. And then Eco-Friendly Tattoo Supplies has a couple of links to places that have eco-friendly tattoo supplies. Okay, now I thank you everybody for this, being patient while we get to this awesome interview. I'm going to ping myself into the background and let Guy introduce Lauren and John. Okay.
Thank you, Gabe.
Hey,
And
everybody.
thanks everyone for tuning in. And this is super exciting because it's rare to get this kind of a specific inside scientific view of our actual chemistry of our art form. And this is one of these things we take for granted. And as practicing artists across the decades, we've just sort of very carefully tried things out and figured out what was the safest. And so we've got this very broad sense of, okay, this works, this doesn't. We've avoided all these. We've phased out mercuric sulfite. And of course, there's this communication between clients and their artists. If someone has a problem, they'll come back and tell us. If we find the same pigments giving us a problem, we quit using it. We tell the manufacturer, we tell our friends. These things quickly kind of get squeezed out. And it's ended up resulting in what appears to be a fairly safe set of products out there that we've come to really rely on. Now we're looking at threats of pigment bans and things like that. And so it's really feeling like time to get informed. So Dr. John Swierk is here to give us what he's learned. And this is the photochemistry of tattooing. And so we're getting very specific. We've also got Lauren Gregory here with us. She's going to be doing the bulk of the questioning. She is, in addition to being a Reinventing the Tattoo staff member, she is also a longtime pigment industry insider. So she's really got some, she's going to be questioning from a knowledgeable place. I'm very excited to hear what they have to say. I'm going to be popping in every now and then with, I'm a tattooer who doesn't really know a lot of science on this stuff kind of questions. And we also would love to hear your questions in the chat room. And at a point somewhere near the end of our discussion today, Gabe will be reading off those questions. And yeah, hopefully we'll get answers to most of them. John, thank you for joining us here today.
Yeah, it's a real pleasure. Thank you for having me.
Could you tell us a little bit about how you arrived at this particular line of inquiry and where you came from as a scientist?
Yeah, so my background is in looking at how you can use light to drive chemical reactions that are relevant for renewable energy. And so when I got to Binghamton and started my independent career, one of the questions I was really interested in is, could you start thinking about tattoos for medical purposes, sort of as medical diagnostics, right? If you have diabetes, could you have a tattoo that would, read your insulin level in real time and let you know? And it quickly became apparent to me that one, I absolutely did not have the skill level to get anywhere near that kind of a question. But as I was reading, what I started to understand is that there was a lot we didn't understand about tattoos, right? There was sort of, you'd see these kind of pulses of work over the years, but not a lot happening in the United States, not a lot happening recently, a lot of unanswered questions. And, I'd talk to friends and colleagues in the scientific community and I'd say, yeah, isn't this really interesting? Like, we don't understand, why does a tattoo fade, right? I mean, that's a really simple question that I just don't think we know the answer to. And everybody I talked about to it just thought it was fascinating, right? They really liked it. They were really taken by the question. We'd spend a half an hour talking about this and then, get around to talking about what my lab was actually working on. And so I thought, well, let's pitch it to NIH, National Institutes of Health, and see if they'd be interested in funding something along these lines. And they were. And so we have a great team that's trying to answer some of these questions and sort of fill some gaps in our understanding.
Okay. Have you been aware of the recent controversies about pigments, specifically the phthalo blues and greens? And there was some tug of war over legislation in Europe. And as far as I know, it's kind of on hold for the time being. I don't really know the details because this is sort of a developing situation. This is a bill that's come through the United States as well and has also been stalled for the time being, and I think actually was killed on the House floor, but it may come back, especially if such a thing happens in Europe. Have you been following this?
A little bit. And I think what's motivating some of that is, at least my understanding, is that you can have copper phthalocyanins that we think are relatively safe. They're sort of similar to in structure to the pigments in plants, right? To kind of, you squint your eyes and look at it that way. The problem is that the version that has fluorine on it is not as safe. And they're somewhat hard to distinguish. So there was some work out of Europe maybe about 10 years ago that found the fluorinated version showing up in a lot of pigments. So if you've got, high-end chemical equipment, you can spot the difference pretty easily. But if you don't, they're a little bit indistinguishable. And I think that's, I haven't followed it in great detail, but I think that's what's motivating it, is that it can be difficult to distinguish. Are you working with something that we think is relatively safe, or are you actually getting a sample of something that looks and behaves in a lot of ways very similarly, but that we think is a carcinogen? And I think that's a problem that happens a lot in generally with pigments, because, unless you have the tools to dig into it, it can be hard to really understand, am I getting a pure sample of this? Am I getting this specific molecule I think I'm getting, or am I getting something that's similar, but, might have an important difference in terms of how the atoms come together?
Okay, well, before I hand you over to Lauren for her questions, I think that I have one final, like, working tattooist kind of question that I think everyone in this industry would probably be curious to know is, have there actually been documented cases of health issues, skin, lymph, etc., that could provably be traced back to tattoos?
Yeah, that's a really good question. And the answer is a little bit murky. So I'm sure, you and your audience know that there are definite documented issues of long-term allergic responses to tattooings. In particular, red inks are notorious for this. The challenge, I think, is, so, when people ask me, the way I answer this question is, obviously people are not getting tattoos and dropping dead. So there is some degree of, safety. What we don't understand, though, is what we should be looking for. So there's been a couple of studies that have looked for incidences of skin cancer with people that are tattooed, and they haven't necessarily found an obvious correlation there. The problem, as I see it, is that because we don't understand, really understand how these inks are changing in the body, breaking down, I don't think we really know what we need to look for. And beyond that, I think there's an important distinction between somebody who has a tattoo on their back that's not visible or exposed to light versus somebody who may have sleeves and there's a lot more light exposure going on there. What we do know for sure is that the pigments can become mobile, right? There's documented cases of tattoo pigments ending up in lymph nodes that can cause issues. Say, for example, if you have to remove lymph nodes for breast cancer surgery, because of the darkening that happens in those nodes. So we know that the pigments can become mobile, but the problem is we don't know how they're becoming mobile, what is actually getting out into the body, and as a consequence, what do we need to look for? And so that's sort of where we see our role, is just trying to say, well, what should we be asking about? At least in some respects, right? Where should we be looking to understand if there's even a concern? And there may not be. I think from my perspective, we don't know well enough, though, whether or not there is something to some problem that we're unaware of.
Right. Yeah, I guess one of the other things that I don't remember where I heard this, but from personal experience, I could back this up, is, one thing that will very much mobilize these pigments is getting laser treatments.
Mhm.
And particularly the color pigments, they're probably going to undergo some, complex chemical changes under the laser. I know that blacks break apart the most easily, and they tend to be, carbon-based, more, simple kind of things, and are probably not as much of an issue. But my wife has had some blue pigments lasered, and this is a long time ago. And shortly after that, she had a lymph node in the bottom of her chin, which kind of like filled up and stiffened, right?
Mhm.
So, and one of the things that I think I'd asked you about Dr. Chris Sperry earlier, he had said that yes, we definitely do collect some pigment in the lymph nodes, but that there hadn't been any documented issues as a result of that. And we collect other things in our lymph nodes too.
Part of the problem is that in general, tattoos, I think from a funding perspective, both in this country and Europe, are generally sort of looked at as an elective cosmetic decision. And therefore, if there's a medical consequence, so be it. That's, the individual's choice. And so there's not a lot of eagerness to fund work that looks into these things, right? There's not a lot of money out there to fund sort of large scale studies to try to understand, again, what's going on and where there may or may not be a potential concern. And so, it's something that, and again, as you know, not all part of the other problem is not all tattoos are created equal, right? There's no standardization of inks. There's not even necessarily, how it's done in the US isn't necessarily the same as how it's done in Europe. I mean, as you know, each individual artist there can be some variation in like the depth of the embedding. So there's all of these factors that are not easy to tease out. And at the same time, there's not a lot of effort being put into developing the kind of large scale studies that are really required to look at the different factors individually and spot things going on. So there's, a small community of us that are trying to ask some of these questions and at least provide some sense of, what do we need to think about?
Yeah, we had another scientist on our channel last week, Dr. Dieter Wolf, who was an archaeologist, and he's been studying tools from thousands of years ago that have been used for tattooing. And there was a perception for a while when they first found Ötzi, the Iceman. They found tattoos on him, and these academics are like, "Aha! Well, clearly he was part of a criminal gang. I guess they had criminal gangs back then, and I guess his fellow gang members waylaid him and took his gold and killed him and left him in the ice. And yeah, look at those tattoos, right?" And that's in stark contrast to what we know about indigenous cultures that tattoo each other today,
Mhm.
where it's a rite of passage that's expected of you if you're going to be an adult. If you are royalty, you're going to have a particularly magnificent set of tattoos. So that, I mean, our anthropologists know this about tattoos, and yet they still ended up filtering through this idea of this kind of 1950s look at this drifter with his tattoos that he got while he was in prison, and so it's just now there's starting to be this sort of eye-opening moment of, oh wow, okay, this is a mainstream human culture thing that has always been around, and it's around on a very large scale right now. And so at bare minimum, maybe it just needs to be looked at as a public health issue, the same way you would look at food safety and that kind of thing. Because yeah, it's elective if you want to eat junk food or not eat junk food, but we should still know whether the junk food is going to kill the people that eat it or not, right? I mean, that makes sense.
I completely agree. And I would say, there's a lot of research on smoking, alcohol, usage, and so I think there is some bias in this too. in terms of how these things are viewed. And, of course, there are, beyond that, actual medical applications, from a cosmetic standpoint, people that have had reconstructive surgery. So I think they're important questions to be asked. Obviously, I think they're important questions since, we've got a lot of work going on this. But, when you consider the scale of tattooing globally versus the number of people that are working on it, it's very small. And so we're trying to identify the questions that we can realistically answer and at least help set a baseline that maybe could be used to advocate for more research, more funding.
Nice. Well, I think that a little bit more work going on between the scientific community and the tattoo community. I think that if we had more communication, we're able to share more experiences and data. We could actually achieve some remarkable things.
We love chatting with tattooers, and we try to start there so that we're looking at things that are relevant and not irrelevant.
All right. Well, on that note, I'm going to hand you over to Lauren. She's got some questions prepared that are much more scientific, and I'm going to be lurking in the shadows here. I'm going to mute myself, and I'll be popping back on later on before we hit the audience questions. So, yeah, thanks again for joining us.
Yeah, thank you.
Thank you, guys. Can you hear me all right, John?
Yeah, loud and clear.
Great. Cool. I love hearing from you. So connected a little while ago, kind of touched on a few things we'll talk about, but for the viewers here, I would love to talk about your current research. Like, what is a day in the life of studying these things, like the equipment used, and can you shed some light on that?
Yeah. So we have a few sort of parallel research streams going on. There are a couple of students and a collaborator on the team that are working on growing human dermal cells. Okay. At least as a model, right? It's not a perfect model for skin, but it's a start. Mm-hmm. And trying to look at how do these dermal cells react to tattoo inks? How do they react when we start illuminating those inks with light? And the idea there being, are we, if we have red ink present and we start illuminating it, do we see a massive die-off in cells, or do we see something strange happening there? So trying to kind of understand, okay, are we releasing some sort of hazard, some sort of toxic decomposition product? What's going on there? We've got another sort of stream looking at what's actually happening at sort of a molecular level when we start illuminating these things. So, if we hit them with a laser versus if we just sort of hit them with, white light, sort of simulated sunlight, can we actually quantify, if we start with pigment yellow 77, for example, what does that break down into, right? What are the molecular components there? And again, try to understand, maybe the pigment that we're starting with is, there aren't any concerns, but by the time it undergoes some photochemistry, some changes with light, it may be releasing something that's a known hazard. So can we understand what's going on there? We've got another direction working with a great collaborator in Texas, trying to actually understand how laser tattoo removal works. So, it may surprise you in your audience, laser tattoo removal is something like an $11 billion a year industry. And the science underpinning it is purely speculative, right? When you follow the chain of research back, you find out that the whole industry is based on a paper that has nothing to do with tattoos. It has nothing to do with the materials that are in tattoos. It's a completely different system. And so we believe that what's actually happening when you're zapping these things with a laser is, at best a matter of speculation. And so our collaborators have techniques to actually sort of watch the laser hit the tattoo ink and then see what happens. Does it fragment in real time, or, is something else happening that's killing off the cells around it, what's going on. And then the last sort of area we work on is just trying to understand what's in commercial tattoo inks. So for example, I don't remember the specific supplier, but we purchased something like 20 or 30 inks from a company, and we looked at their safety data sheet, and they're all the exact same, right? There's no chemical information there. There's no specific information as to what's going into these pigments. Some manufacturers disclose that, some don't. In Europe, when there was sort of a pulse of research on this about a decade ago, there were a few studies that looked at what was in tattoo inks. And almost universally, they found that in the inks they looked at, there were presence of metals that weren't listed in the ink on the ink labels. There were issues where the inks were mislabeled. So what we were talking about earlier with the phthalocyanins, that heavy metal levels were much higher than you would predict. And what's interesting about the last example is that the method they used to break the inks down, when we tried to replicate it, we learned it doesn't actually break the inks down all the way. So that snapshot was incomplete. So we do a lot of work just studying inks themselves. We use what's known as microwave digestion. So it's basically an ultra intense microwave that causes very high heating under pressure. And we do that because if there are metal containing components in the inks, we put strong acids in with those inks, and that breaks the inks down, and then we can quantify the metal in those inks. We do a lot of electron microscopy to actually look at the structure of these inks, on a very small scale to try to see, what's going into it. Are we looking at sort of small nanomaterials that there may be some concerns about them becoming mobile in the body, or, is it sort of big bricks of pigment or something in between? And we do some other work, just again, trying to quantify what's actually in the pigment. Is it what, in the case where we have some information, is it what's on the label, or is there something else in there? Early returns suggest that the issue of mislabeling or incomplete labeling may also be present in some of the inks that we've looked at. It's certainly, not necessarily all of the inks in this country, but we're finding inks that are only supposed to contain copper, and when we digest them, there's something else in there, probably cobalt. So that's sort of how we approach this. And the goal with the last part, looking at the inks, is partly to inform the other areas of research, so we know what we should be looking at in terms of, making our own inks to test things. Should there be solids, molecular pigments, a combination of both? Excuse me. And then also our long-term goal with that is to start making this data available to the wider community, so that there is some degree of insight. If you're choosing your inks, then you have a customer who's got a chromium allergy, that we can say, look, this ink is full of chromium, this might not be a good choice. And also try to create at least a snapshot of what is in the inks now, so that 10 or 20 years from now we have some record in case we need it at that point.
Absolutely. That actually brings me to ask you about what's in MyInccom and the efforts you've made there. It's a great resource. I've checked it out. It's got a lot of different compositional things listed there. Can you tell us a little bit about that?
Yeah. So, one of the things we learned really early on when we started thinking about this, and I think it's obvious to everybody here, but that the world of tattooers is it's a very professional community, right? You know, that it's a community that takes
Absolutely.
things very seriously, you know, that you know, safety, hygiene was really important. And what we felt was that, you know, there's this kind of gap in our understanding of inks, right? I'm not necessarily advocating for FDA oversight, but there is, you know, at present, the FDA chooses not to exercise their oversight except
Yeah.
in very limited cases. And so when we started talking to tattooers in our area and saying, well, okay, what are you using for inks? Where do you get them from? What do you know about them, right? You know, what do you tell us what you understand are in the inks, what you understand about the safety? We realized there was this sort of gap. And what I couldn't shake the concern of was that, you know, there was this potential for mischief, right? Because there is no, you know, there's nobody really sort of checking in terms of what's going in these inks. And, you know, the popularity of tattoos is exploding, that I worried it could create the kind of environment where, you know, somebody who was somewhat unscrupulous could, you know, start throwing some inks together. And as Guy pointed out, you know, that may not last on the market for very long, but, you know, that's going to go into people. And it could have an impact. So that really bothered me, that, you know, tattooers and their clients were sort of obligated to kind of take everything at face value. And so we wanted to bridge that gap and create a resource that, you know, a tattooer could go to, look at what's in the ink, you know, try to provide some insight in terms of our best understanding of the literature. You know, is this a potential hazard in here? Is this not a potential hazard? This is what we know. You know, we're not saying use it or don't use it, but this is the best information we have. You know, do with that what you will. And our long-term goal is, you know, there's so many inks out there, and of course, there's always new batches being made. We're also trying to develop, take what we're doing in our lab with, you know, sort of high-end research equipment and start developing analogs for high school and general chemistry labs at colleges to start screening these tattoo inks. You know, will they be able to achieve the same level of analysis that we can? Probably not, but our hope is that they might be able to start identifying inks that could be problematic. And then we can focus our efforts on studying those inks and flagging something if there's a problem early on, before, you know, it takes, you know, a bunch of people having some horrible reaction to it and, you know, sort of word zipping around the community.
Interesting. So can you tell us about some of the chemical reactions that you're seeing that are initiated by light?
So that's an interesting question. And, you know, I want to think about how I want to answer this. Because again, we haven't published a lot of our work yet. So there, you know, I have to be careful what I can't disclose too many specifics yet. But generally, right, what's known in the literature, and we've seen the same thing, is you know, under intense illumination, you know, you can see pigments break down. You know, I put out pigment yellow 77, for example. There's a very nice detailed study that shows it can break down into a variety of photo products. One of the challenges, though, with all of the studies that are out there is they're all done in what we would call non-aqueous solvents. So they're not done in water, right? So it's more akin to what you would use for like paint thinner than, say, trying to mimic the environment of the human body. And so we're not clear right now how much that work translates over to a human model. There is some really nice work out of Germany that has demonstrated, I think with a couple of red pigments, the formation of some photoproducts in the skin. Generally what happens, right, you can think about, pigment molecules as sort of being large, large sort of molecules with sort of distinct sections kind of stitched together. And that's what gives it the light. And so what sort of seems to happen is it'll kind of break apart, into the sort of building blocks. But of course, in a biological environment, you have proteins, you have lots of stuff kind of floating around. And it's not clear where all that chemistry is going. And so we're trying to follow it out. And so at the moment we've been looking at, taking systems that people have looked at outside of water, seeing what's happening there, and then trying to now do it in water and seeing what it breaks down into. The problem is it doesn't go from one thing to another thing. It goes from one thing to 16 things, and it takes a while to break those 16 things down and figure out, what's different about this component versus that component, because they can be kind of similar. So we're getting there, but we don't have a totally clear picture yet. And we eventually want to start looking at what happens when you throw some model proteins in there. Can you start sticking these things to proteins? Where do they go?
Sure. How relevant do you think it would be to study people who have had tattoos over time? Is there a way to, I know that you're working on the skin and such as things like that, but how valuable would that information to be to someone like you?
So, in the abstract, it's tremendously valuable. But the problem is when you start involving, so the reason that tattoo research in Europe fell off is that when you start involving people or animal models, the level of complication goes up tenfold. There's a lot more involved in terms of internal review boards, NIH level kind of regulations. And so even looking at animal models is challenging. And so up until about a decade ago, in Europe, you could use an animal model to study tattoos. And so people were using rats, they were using pigs, they were using whatever. The EU changed those regulations to prevent that. And so as a consequence, it's really, really difficult to do work on tattoos with living subjects. Even collecting data, we have to be from people that have tattoos, we have to be careful because it's very easy to misstep. And these policies are in place for good reason, right? They're there to try to prevent abuse of medical information and things like that. But it's very difficult within science to do that kind of work, to even just to talk, let alone say like taking a small skin sample, something like that. It's very challenging to get approval to do that. And that's not even the kind of work that we typically do. Mm-hmm. So there's an extra bar there for us. I think the next step is working with collaborators that can grow better models of artificial skin than what we're working with, and try to get a little bit closer to something that looks more like human skin. But even that's there's a real art form to that, and it requires a lot of highly specialized equipment and knowledge.
Very interesting. Can you tell us a little bit about the methods that you're using here, whether it's spectroscopic or electroanalytical, or others that you're using?
Yeah.
research?
So, I mentioned before we use a lot of characterization equipment. So, electron microscopy. We use some. So when we talk about a spectroscopic technique, right, that's something that's using light to probe something,
Mhm.
right? And so, most of these pigments, most molecules will absorb certain colors of light and not other ones. And so that makes kind of a molecular fingerprint, right? We can say, okay, this molecule absorbs like that, but this one absorbs with this shape over here. So we have this and not that. So we've been doing some work, just to sort of see where the tattoo pigments are actually absorbing. I think most of that's actually available on What's in My Ink to see, where the wavelengths of light kick in, and can we identify maybe certain components of the different pigments or the molecules. Um, my lab does a lot of work with lasers, trying to use lasers as a tool to watch what happens at very short times. So if you want to observe some process in chemistry that happens on a sub-millisecond time scale, usually you have to use light to do it. And so we do a lot of what's known as transient absorption spectroscopy, where we'll use a laser to start a reaction and then watch with light over time, from nanoseconds and longer, as we go from something that looks like this for an absorbance to something that looks like this to something that looks like this. And we can sort of use those fingerprints to follow what's going on in time. In Texas, we're using a really interesting technique called nanosecond shadowgraphy. And so this is, if you've ever, had a candle and, held your hand up to make like a barking dog, it's the same idea. But what happens is a laser comes in to strike the surface of the tattoo pigment or whatever you want to study. And then another laser comes from behind it. And that second laser sort of backlights it, just like you would with a candle and a barking dog. And so we can watch basically in real time as the laser hits, right? And then, by changing when this laser hits and this laser hits, we can go from the moment of impact out much farther in time and actually watch as we see some local heating, and then, maybe there's fragmentation or shock waves produced. At least in general, that's how the technique works. And so we're trying to, we're in the process of figuring out how we can make supported samples of tattoo inks that we can then zap with the laser and put into this system. Unfortunately, COVID-19 has really impacted our ability to move as quickly on this as we'd like to, but we're getting there. So we throw a lot of things at it, basically.
Do you see a stark contrast in results of laser versus sunlight? And if laser is very dangerous in causing such a carcinogenic reaction, would it pay in mind to invest in research developing other tattoo removal techniques?
Yeah. So, I don't want to say that we know for sure now that there is a specific hazard with lasers. We don't know that, but we don't know either way yet. There's a really interesting group in Denmark that has a clinic that's all entirely focused on tattoos. And they're developing a technique of tattoo removal that, it sounds a little intense, but basically they're sort of shaving the skin off. It's an established medical procedure already. But their argument is, if there is a problem with the pigments, right, and most of the time it's allergy related, if we do laser tattoo removal, that pigment is going to go somewhere within the body.
Yeah.
Right? If we shave that off in a sort of controlled medical way, we're taking all that pigment away. And so they're, last I knew, they had made some really interesting strides in that direction. And I think if I had to have a tattoo removed right now, I would probably want to do this dermatome shaving over, say,
Sure.
laser tattoo removal. Not to be too critical of laser tattoo removal, but you know, for us, right? We have a class 4 laser, same thing that you would have in a medical environment. It took us 6 months of approvals, documented safety trainings, a lot of things in place to prevent, uh, possible hazards or dangers. If you want to get into laser tattoo removal, as far as I understand, it takes about a weekend. And so, there's, again, it's an area where I don't know that there's a lot of insight, and it concerns me because the whole industry is based on this model of the laser comes in, it causes the tattoo pigments to fragment, and then, they can become mobile and the body can remove them. And I'm not convinced yet that that's the correct model.
Sure.
And so I don't think we really know well enough what's going on, and that makes me a little reluctant to wholeheartedly endorse that.
Yeah, I agree too. There's I guess a lot more heavy speculation now because that's kind of a hot topic in the industry, the laser removal process. And if that didn't need to be there, would the results still be the same? Something to worry about.
Right. And I think the rationale for underlining a lot of what we do, the fact that light can cause things to change, is demonstrated by the fact that it's not uncommon with laser tattoo removal for the pigment, the embedded pigments to change color when exposed to the laser, right? So that's a very obvious example of light driving some kind of chemical transformation.
Sure.
That's not at all uncommon.
Very interesting. So I know that we do have to close off here in a couple of minutes. So I'm curious how you would say, how does analytical chemistry, material science, cell biology, how does that translate to your everyday tattooer?
Yeah. So, a lot of what motivates us is, we genuinely want to empower the people in your community to have the best products and the best outcomes for your clients. Somebody asked me at one point, are you anti-tattoo? And I said, no, not at all, right? There's a lot of people in the lab that have tattoos. There's people that have gotten more tattoos since they started working on it. We have expertise and we have access to tools that most people don't. So we can provide some oversight here, and at the same time, hopefully do some interesting science. But our goal is to take the skill set and the tools that we have and help empower tattoo artists, clients, even ink manufacturers to develop the best products, the safest products. Beyond that, when we talked to tattooers, why do you like this ink? Why don't you like that ink? It's not uncommon to hear things like, oh, this ink doesn't suspend very well. I don't know why, this one fades. This one's hard to work with the guns. That's all sort of material science. It's chemistry. It's the kind of things that, people in my world think a lot about and sort of know how to address a lot of those questions too. So along the way, we also think we may be able to help contribute to some understanding of, well, how do you make a better tattoo ink just from a usability standpoint? So that's where we see our role and how we feel like we can interface, with the community of, tattooers and tattoo enthusiasts is not in trying to cause problems, but in trying to really empower a community of really dedicated, serious professionals to be in a position to do the best job they can.
That is awesome. I love hearing that. My last question for you.
Yeah.
When you initially decided to kind of push forward with the NIH funding. Can you tell me about that experience a little bit and how you felt? Like, what were you telling yourself? Like, I'm going to go for this. I know I can do it. And then just a little process about that.
Yeah, I knew there was a lot of interest in the area, just from talking to people, right?
Sure.
That it was an idea that people liked. And I sort of decided, all right, well, let's throw a grant proposal out there, and I'll just sort of see what they say, right? I don't think it's going to get funded. That's okay. Most of the time it doesn't. You got to resubmit a couple times, address reviewer criticisms. I was really surprised, to be honest with you, when it got funded right off the bat. And I think everybody sort of was, and the level of enthusiasm for it was pretty high. And we were very fortunate to work with a good program officer in NIH that helped us sort of adapt a few things, and kind of work us through the process when it became clear that the reviewers for the grant really liked it and thought it should be funded. So I mean, it was a genuine shock. I was at home for COVID. I'm still at home for COVID. And when you submit a grant to NIH, you get a score, right? And if it's below a certain level, it's usually fundable. And I got the score at like 11 o'clock at night. And I was, like, I don't think I fell asleep till 4 o'clock in the morning. I was so shocked. So it was a pretty wild experience. And to be honest with you, a little unexpected, but
that is great.
Yeah. So here we are.
Yeah. And then gathered your team.
Yeah. I do have a couple questions from the chat rooms, and then Guy just beamed on, so I just want to make sure that we have a little bit of time for everything. So Guy, let's see what you have, and then we'll.
Yeah. I've just been kind of lurking in the background and trying to imagine the sort of questions that have popped up for me and my my colleagues and I over the years. And you did touch on particle size a little bit and how these particles break down. And of course, color is a consequence of fine structure, right? I mean, it's basically got to be have a structure that interferes certain wavelengths of light in order to appear to be that color, because color is actually just a function of wavelength of light. So as these pigments break down, they lose that fine structure. Do they also sort of gray out as a result of that?
What happens is, they shift from maybe absorbing visible light to absorbing more like ultraviolet light. Because sooner or later, all molecules will absorb light. It's just some molecules will only absorb very high energy light. And so what happens is that because you lose that absorbance in the visible, your eyes don't pick up that new absorbance in the ultraviolet. And so as a consequence, it fades, it loses that. That's for molecular pigments. There are, and we don't understand, honestly, at this point, how widespread it is, but there are certainly solid components to some tattoo inks that are not, molecular pigments. So TiO2, for example, titania, super common in white pigments, or white inks. And there, we start thinking about particle size, because, and again, there is some research, although not sort of systematic, and certainly not from this country, that you can have particles of TiO2 that are, below 100 nanometers. So they're what we would call a true nanoparticle. And as you get smaller, those can become mobile within the body, and they can pass through cell membranes and start doing all sorts of mischief.
Right.
So nanoparticles themselves can be a carcinogen just because of their size. And so that's one of the things we want to understand is, do we have a whole bunch of, small nanoparticles floating around? And if we start whacking them with lasers, do we, shoot nanoparticles throughout your body?
Right. Now, I know that there was a period there where nanoscale titanium dioxide was very widespread in cosmetics and things like that. And I think that there was sort of a pullback from that. But one of the essential features of these particles is they're kind of needle shaped. They're cigar shaped basically, and they might work really well in something like a sunscreen. But I think one of the things that we've recognized as tattooers is that below a certain size, particles don't stay in the skin very well, and they don't reflect light very well. So I think that was another question that I had for you, was about particle size in terms of healing into the skin and staying there. And if, there's been any kind of observations in terms of, this seems to get mobile very easily and wash away, while this seems to stay put.
I think there is a lot of informed speculation, but I don't know that there's documented science on that, because again, it's a challenging question that sort of requires moving between sort of model systems like we look at to more authentically biological systems, and when you do that, it can be challenging to get that kind of work approved.
Right, gotcha. Yeah, and then of course the idea of getting tattooists and tattoo collectors to broadly participate in very detailed questionnaires, that gets tricky as well, and it's hard to keep opinions separated from facts and that kind of thing. But it certainly would be interesting, because I think ultimately, no one wants to drive a popular art form back into the underground. We know what happens then. People don't stop practicing it. It just goes to the black market, and all the consequences that come with that. So cooperation between disciplines, I think, is essential. So if there was a way that the tattoo profession and the scientific disciplines could regularly communicate on this subject, have the latest findings, maybe even safe lists. I guess this would be another question. My final question before we go over to the chat room is, what does an artist do if they want to have a pigment tested for safety? Is there a way to do that?
No. We're trying to provide some insight there, but I have to be careful to say that we can't, we're not in a position to say, yes, this is safe, no, that's not safe. The best we can say, well, look, there's a lot of nickel in this. Nickel can cause some problems. We see a whole bunch of nanoparticles in this. We know nanoparticles can cause a problem, but but there is no sort of like underwriter's laboratory for tattooings. I wonder if maybe there should be, but at the present moment in time, there is not. And so we're trying to provide some crossover there.
I guess the thing I would just say to artists and collectors too is, the pigments that you use, reputation really is everything. Talk to other artists, ask them what they're using, ask them how long they've been using them. When a new product line comes out, I don't just start using it. Wow, this looks great. Because I know that might result in me having to fix my work and my reputation. And so once it's been recommended to me strongly by several trusted colleagues, I'll consider it. And even then I'll phase it in slowly. You really have to take these things when it comes to the actual chemical substances that you're putting in the skin, not just pigments, but things like tattoo glides and foaming soaps and things like that. All of these things really need to be considered from a long-term perspective. Ask people who've been using them. Make sure that there is a reputation there, that it's got a history of not giving people problems. You can find out this information. You shouldn't have to just stumble around in the dark.
Hey guys, sorry to cut everybody off, but we do have a hard out here, and we do have a good set of questions. So we're wondering, John, would you be willing to maybe come back for another half hour to do this at another time, or to record something and then we could release it? Or
I'd love to. I mean, a big part of what we're trying to do is to, just like Guy said, create some bridge there and transfer what we know right now to your community and so yeah, I'd love
Well,
to
great.
come back on and
We'll have to end on the cliffhanger. There has been a lot of talk that people think that this research is going to enable big corporations to take over the ink business. And I feel like obviously we can't open up that can of worms 1 minute past your heart out, but everyone will have to stay tuned to get that to get our inside scoop on that, I guess.
yeah.
And anyone who watches this and has questions, submit them to us. And when we get back together with John, we will be able to, go into some detail.
Yeah, I'd love to come back and chat. I'm happy to work with you and we'll set something up.
Fantastic. Well, thank you so much for coming on. This has been very illuminating. Thank you, Lauren, for helping with the questions. This has all been fantastic.
Thank you so much for having me.
Awesome.
Thank you,
Okay,
Jen.
now's the time everyone has to wave and make funny faces.